Hello and welcome. I am Teacher Mary Chu, and our topic for this video focuses on the enrichment activity of the Senior High School General Mathematics for Quarter 1, Week 3D. The thorough discussion of this learning activity sheet is on the description below. For the objective of this learning activity sheet, we have the learner solves problems involving rational inequality. Let's get started. Enrichment activity. We have here the problem. Let me read it out to you. Handicraft in mathematics. You are supposed to make a pencil box holder made with a square base and has a volume of 1,000 cubic centimeters, or that is equivalent to 1,000 ml or milliliters. What will be the measure of the side of its base that will make its surface area less than 525 square centimeters? Now, of course, why surface area? Because we are limiting or minimizing the use of a material to be used in making the pencil holder box. So we are to minimize that the surface area of this pencil holder box will only be less than 525 square centimeters. And we have a hint. The volume of this box is equal to the length in its base, and of course the width of the base and the height. And we are also given here the surface area formula. Since this is an open box, then we have S squared. Only the bottom part of the box will be covered with whatever material you are available, plus the area of the four faces of the box. That is 4S, or the side, times the height. So if we are considering this area, for example, this one, of course, one of the side or the width of this rectangle here is, let's say, S, and the length is the height, H, in this formula. So let's move on to our solution. Okay, General Mathematics Quarter 1 3D Enrichment Activity. Solution, we will use X instead of S. Either, you can use any variable if you wish. Now, let X be the side of the box with a square base, and let H be the height of this pencil holder box. For the volume, we are given to be X squared times the height. Of course, we have an open top. And the given in the problem is that we have 1,000 ml, or just that is equivalent also to 1 liter. 1 liter or 1,000 cubic centimeters is equal, that's the volume. So this is equal to, simplifying this, that is X squared times the height. Then we solve, or we express the height in terms of the width or the side of the base. So that is 1,000 divided by X squared, meaning in this formula you have isolating H, we have to multiply both sides of the equation by 1 over X squared, and we have this one. Now for the surface area, we have given in the problem is S squared plus 4S times H. But in our case, let's use the X. So in terms of X, the function surface area of X equals X squared plus 4 times X times the height, which is given to be 1,000 over X squared. Simplifying this rational expression, we have X squared plus the X here in the numerator of the second term of the surface area formula will be cancelled out with 1x in the denominator. So that becomes now 4 times 1,000, 4,000 all over x. So it says here, finding x in such a way that the surface area must be less than 525 square centimeters. So let's have S of x above. So we copy less than 525. Then we have to make, this is now a rational inequality. And we have to make the right hand side of this rational inequality 0. So we have to, by the addition property of inequality, or sometimes I call it API, addition property of inequality, we have to add negative 525 here. Then we have also to add on this side negative 525. So to simplify, this becomes now x squared plus 4,000 over x minus 525 less than 0. Okay, I missed one step, but I just want to fast track this step. So I just go directly to the simplified, which contains already the least common denominator, which is x. Then the LCD here in these three terms, or the transpose, the constant is already here. Assuming, just imagine it, three terms already here in the left hand side of the inequality. So we have to multiply by the LCD x. So multiplying each term by the LCD x, we have x squared times x, that's x cubed. Then the 4,000 over x times x plus 4,000. Then the minus 525 times x, it's negative 525x. And in this case, we have all over x. And of course, less than, we just copy the less than symbol or the inequality less than. And of course, this 0 was multiplied also by x. But any number multiplied to 0 is always 0. Now, it says here, rearranging the terms, we have here x cubed minus 525x plus 4,000 all over x is less than 0. Now, we have this rational inequality, and we have to solve for the critical values of x, or what are the values of the side of that pencil holder box that we are going, or you are going to create in order for you to have the surface area less than 525 cubic, or 525 square centimeters. To move on, we have to set both the numerator and denominator equal to 0 in order to find those critical values for x. Let me go first directly to the denominator because it's a simple one. So equate that to x. That means that x equal, or s, or x equals 0 is one of the critical values. But anyhow, if x is 0, there's no point of having that pencil holder box. But let's move on, just for the sake of mathematical discussion on this particular problem. Then we have a complicated, not so really complicated, we have to make it simplified. Okay, numerator x cubed minus 525x plus 4,000, set that equal to 0. Then we have to factor this out. But using manually, it's so impossible. It's not feasible for me to do it. So I searched on the internet online while doing this video and while formulating the solutions for this particular problem. I encountered this Desmos graphing calculator. It's online, so just try to search the internet online for those graphing calculator for you to just input this x cubed minus 525x plus 4,000. What I did here is to examine the graph. Then, having the zeros of that graph, meaning focusing on the part of the graph or the point of the graph that touches the x-axis. It is where the function x cubed minus 525x plus 4,000 equal to 0. And it's not really a whole number, and I rounded off that to 3 decimal places. So these are the factors. And later on, just to convince us that it's really these 3 values for x and these three factors are really the factors of the given polynomial function, we will use the factor theorem. But for now, let's take it as it is, that the factors of x cubed minus 525 plus 4000 equals 0. This expression will become quantity x minus 9.014 times x minus 17.034 times quantity x plus 26.049 equals 0. So moving on, set this first linear factor to 0. Then we get the value of x equals 9.014. Then the second factor, set this equal to 0. Then that would become x equals 17.034. And the third factor, x plus 26.049, set that equal to 0. Then we have x equals negative 26.049. Now, let us see what is the idea behind this. Well, in this age, technology is really rampant and we have a rapid exponential growth of technology every second, every minute of the day. So, but then, it boils down to the long time formulated factor theorem. It says here, my source for the book where I got this factor theorem is the MSA Advanced Algebra book. By using the factor theorem, let me give it out, sorry. It's this one, the factor theorem. Let f of x or function of x be a polynomial. In this case, our f of x is x cubed minus 525x plus 4000. That's a polynomial, equals 0. Then f of c, if f of c equals 0, meaning if we set the function, if x equals c, and we evaluate that in the function f of x, and we found it to be 0, then x minus c is a factor of the function f of x. And the converse of this theorem is also true. If x minus c is a factor of a function, then f of c equals 0. So either way of this factor theorem, it's gonna be true for this particular example. So let me continue here by using the factor theorem. Let us verify the following values of x. To verify that x is equal to 9.014, 17.034, and negative 26.049 are the zeros of the given polynomial x cubed minus 525x plus 4000 equals 0. What is f of 9.014? Well, convince yourself. You can pause this video and you can get your calculator and calculate it with me. So this is your basis here. So this is our x, cube it, minus 525 times this x at 9.014 plus 4000. Is this really equal to 0? Calculate it yourself. And actually, you can find in your calculator, it's 0.0572947 or obviously that is estimated to be equal to 0. And yes, it's equal to 0. Then we can say by the factor theorem that quantity x, or simply x minus 9.014, is a factor of our polynomial. Okay, let's move on to show that 17.034 is also the value of x that will make the function 0. Okay, the value of x, cube it, minus 525 times that x, this x, then plus 4000. Then we got negative 0.3130473, approximately equal to 0. And yes, it is equal to 0. Hence, one of the factors of the given polynomial is also x minus 17.034. And the third factor is negative, the value of x, negative 26.049. Evaluating f of negative 26.049, we have cube this x minus 525 times the value of x here plus 4,000, then it's equal to 0.16560044, estimated or approximately equal to 0. Yes, it is equal to 0. So we found the three factors of the given polynomial x cubed minus 525x plus 4,000. Okay. Taking the 4, including the 0, the one that will make the denominator 0, so x equals 0, and listing them down in ascending order. So in this case, I had already arranged, of course, the smallest value among these four values is negative 26.049. Then we have the 0, 9.014, and 17.034. These are critical values of the side of the pen holder or the pencil holder box in our rational inequality. Now, to simplify, so that we will not be typing or rewriting this here, so let's give it a name. This inequality x cubed minus 525x plus 4,000 all over x less than 0, let's name it as a heart. Then we have to know the sign of this. Of course, we expect that this final value will be negative in order for us to identify the range of values of the side of the base in order for that pencil holder box to be or having the surface area less than 525 square centimeters. So we have here the sign analysis table, then reflecting the, let's say this is our real number line with x equals 0.26049, x equals 0, x equals 9.014, and x equals 17.034. Then on the row, interval rows, we have here the following intervals. Okay. Then the test points. How to get the test points? Of course, the easiest way to get the test point in this interval from negative infinity to open interval negative infinity to negative 26.049. Of course, the next integer or the next whole number, the next integer, negative numbers are not whole numbers. The next integer less than this value of x is negative 27. That is our test point for this particular interval. The next one, how to get negative 1. This in open interval is from negative 26.049 to 0. So the nearest integer to 0 is negative 1. And it belongs on this interval. So let's have negative 1 as our test point in this particular interval. Now for this interval 0 to 9.014, of course 1. Then in this interval 9.014 to 17.034 open interval, it's 10, higher than 9. And we have 18 in this particular interval. Now let's concentrate on this column, the first column. How did we get negative, 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 and eventually positive? Now let's do this like this. These are the factors in the numerator of our function or our rational inequality, and this is the denominator x. Okay, substituting the value of x in this particular linear factor of the numerator, and that is x plus 26.049. X equals negative 27. Obviously, negative 27 is higher than 26.049, so subtracting them will give us a negative answer, or adding. Then next, if x is negative 27, then negative 27 minus 9.014, it's also negative. Then negative 27 minus 17 point something, it's still negative. And of course, negative 27 is negative. Moving on, we have to operate on this. We have negative times negative, it's positive, times negative, it's negative, times or divide divide by a negative, then it's positive. We're done with column 1. Moving on to column 2, x equals negative 1. Then we have here positive. And then on the next x, that's negative 1 minus 9 point something, so it's still negative. Then negative 1 minus 17, it's still negative. Then for x equals negative. Then positive times negative, it's negative, times another 2 negatives will produce 1 positive. So positive here times positive, but times negative, so it's a negative 1. So here. For this, x equals 1, we have 1 plus 26, so it's positive. Then 1 minus 9 point something, it's negative. Then 1 minus 17 point something, it's negative. Then 1 is equal to 1, then it's positive. So we have 2 negatives, that is positive, and 2 positive is positive. So we have a positive answer in the final, or in the heart here is our rational inequality. Then in this case, it's 10. 10 plus 26 is positive. 10 minus 9 point something, it's still positive. 10 minus 17 negative. Then 10 is equal to itself positive. So in this case, we have 1 negative. So that is our final answer in this particular interval is negative. Then we have the 18, the last one. So 18 plus 26 is positive and all positive. Then of course the resulting inequality here will become positive. Now, but take note, our goal is to have a negative value in the final row, the heart row here. In the heart row, it must be negative. So you have seen that this is encircled. That means that is our solution, part of the solution of this given inequality written with a symbol heart. But you will notice that this is a negative, or meaning this is on the left side of 0 and irrelevant since x is negative, or meaning we cannot have a negative for the side of the pencil holder box. So we have to get this interval here, and this interval falls on the open interval 9.014 to 17.034 for the value of the side of the pencil holder. So we can say our conclusion here is, hence, the measure of the side of the base of a pencil holder box that will make its surface area less than 525 square meters lies on the open interval 9.014 to 17.034. Or simply, of course, we have to take the values of x in such a way that it's a whole number. Remember, x is the side in centimeters, so we can have x equals 10 centimeters, 11, 12, and so on, up to 17 centimeters. These are only the values of x that will satisfy the making of the pencil holder box in such a way that the area or the surface area is less than 525 square. I'm sorry, it should be 525 square centimeters. Correction here. Okay. So this is all for now. I hope you had enjoyed this video and my discussion. See you on the next discussion. And this is again Teacher Marichu saying always stay happy, healthy, and always safe. God bless.